Hello, everyone. From the previous sessions, we've understood how the SambaNova hardware looks like, how the software stack is built, and also have seen how you take your PyTorch code and actually port it to the SambaNova. It's now we get a one step ahead and see actually how we run this on the SambaNova system. Just pardon me a second. I'm not able to move my screen. Yeah. So in this particular presentation, we'll quickly look at how actually the SambaNova cluster looks like at the ALCF and what it is necessary to have access and how we really get access to the system. This is typically useful for all the new users who've never used SambaNova before. I know some of the participants here today have already been using SambaNova in the past, and that's a good refresher for most of them. Then also we'll take a look at as to how we log into the system, what are the different steps, and how to set up a working environment on the system. And we'll also figure out how an end-to-end flow looks like. We've seen and heard about compile, run, and so on and so forth till now. But we'll take an actual look as to how we perform and execute these on the system. And finally, we'll also have an example program like an MNIST or like an Hello World program for us, and also like a data parallel program, and how we execute on these systems. So here at ALCF, we have SambaNova DataScale SN30, which is a very prominent AI testbed. We've had different science application already successfully ported on the system. So the system here looks like is that we have 4 racks, and each rack has multiple nodes. It has 2 nodes to be specific. So totally we have 8 nodes of SN30 in the ALCF. And each of these nodes are built up of RDUs, 8 RDUs to be precise. And also we couple 2 RDUs and we call it as an XRDU just for hierarchical reasons. And each RDU is again split into 8 tiles. So if you will hear a lot of jargons about tiles, RDUs, nodes, and racks. Just to be specific, that you have like a group of 4 tiles where you can actually successfully use it to port one of your smaller models. And then you can also scale it across, say, different number of tiles or across the RDUs, or you can use the same and you can scale it on to different number of RDUs and nodes, and even racks as well. As we've seen, we have like these 8 different nodes here at ALCF. Each of these nodes are specified by the different names that we have. When we say SN30, which is the system we are talking about, and then we have the numbers specified by R, meaning rack. So R1 here means it's rack 1, and the H1 here, for example, is the host. So there is a combination of the rack and the host numbers associated with each of the node. And you can successfully log into any one of these nodes to execute or run your programs. So now that we've seen, an overview as to how the system actually looks like, An important one-time step is the requirement of an ALCF account to actually use the system. The request for an ALCF account will be provided on this page. I'm pretty sure, like many of you already have an active account. If you have an already existing ALCF account, you can use the same to log into any of the SambaNova nodes. The username is usually the ALCF account username, and also the associated password has a mobile pass plus app, which you will generate a 8-digit token and can be used to every time access both this accounts page as well as anytime you log into the system. Just give me a second. Can people see my screen properly?
Yeah, we can see your browser window.
Now?
Yeah, can you? Yeah, perfect. Yeah.
Okay, sorry. Yeah. So once we get on to that the account page, you can request for joining the project, and you can use the SN training for this particular training session. And once you have the access approved for the SambaNova systems, you can always look at the request and review page, and you should see the SambaNova as part of your available resources under the current section. If you do not see that, then please use the help channel and the support channel at the ALCF to reach out and to fix the underlying issue. So once you have the access, the next step is to actually physically logging into these SN30 nodes. So as you can see from the figure here, you have your local machine. This is a two-step process. So first, you log into any of the login node using your username at the SambaNova.alcf.anl.gov. And then once you move on to the login node, which is usually your SM login node 1 or 2, you can log in next to the specific SM node, which is given by the 8 different nodes that we have already seen, which has the different rack and the host numbers. Next, once we have the login, then we set up the environment. So usually the SDK, which is a SambaFlow stack, and any other associated variables and paths are set up at login. The other advantage is that we also have a pre-built software environments under the given path here, which is the OPT SambaFlow apps. You can see there are for each of the different applications examples that SambaNova already supports and have been provided under the apps section. There is corresponding the pre-built environments, and you can always use anything that is particularly of interest while you're setting up your own applications. Another way is to actually create a new environment and installing the packages, the required packages by yourself. All these commands are provided as part of the ALCF website, as part of the tutorial web page, and also will be sharing these slides so you can easily use them. Now that we know how to log into the system and then kind of get the environment set up, so the main two steps to actually get your application up and running is one is the compile and second is the run. So as part of the compile process, we compile the model, and at the end of the compilation, a .pef file is generated. And this is basically the essential artifact of the compilation process. It actually maps the compute and the memory resources that is required for one to run their applications on the system. As we've already heard from the previous lectures, that the recompilation is only necessary if you are changing the input, the shape to the model, or if there are any particular batch size or any other model parameters or configurations associated with the model. If not, if you're just changing, say, a data set, then you can use an already existing pre-compiled part of the model, and then you can just run the existing, using the existing .pef file. Please do note that for very large models, the compile times may be significant, and you will, please be patient while it compiles. It does take some time, and it is pretty much model specific. Here is just like a small snippet as to how a compile command may look like. We can go through each of these command arguments separately. So we have, so Linet here is just the example application that we are considering. It's the Python file, and it is indicated that it indeed uses the compile for this executable, and then B stands for the batch size, and the pef name is the name that you want to name it. That can be totally your choice, and the output folder also specifies the path where you want to really place this pef file. So this is a very simple example, and in the later stages, we can also take a look as more and more the model gets complicated, as we want to do more data parallel models using data parallel framework, the arguments to the compile will also change. And the second step of this process is the run command, where you do the actual training using the already generated pef file in the previous process. We also pass in the training data set along with the .pef file. So as you see the snippet, you can see that the same file application is being passed, but now it uses, I think there is a small typo here, but it should be, instead of the test, it should be the run command, and you will use the pef file as the input to the command. Oops. Also, as part of the software stack, we've seen that the SambaFlow also provides these examples under the /opt SambaFlow and apps. As you can see, there are, I've just listed a snapshot as to the different directories under that. And you can see you have the different application examples for image, for NLP, which is the natural language processing different models. It houses the major GPT versions of the models. Then you also have like a very simple hello world kind of applications, like the MNIST under the starters. And if you can, go inside the image directory, you can also see the different applications currently that are provided as an example. These are just some of the examples that are already provided by the SambaNova team, but you can always use these as kind of a model, and then you can extend or base your own applications on it, and always can port them on the machine. And there are also some of the already available scripts for these kind of applications under the /data directory. It hosts some of the scripts like for the applications like a GPT 1.5 billion, 13 billion. You can also use, you can also have some of the applications like computer vision applications like UNIT, some specific applications to ANL like UNO. And basically, if you take a look at these scripts, it's just a combination of your compile arguments and your run arguments, along with some of the environment variables that are set. So for the example, like we start off with a hello world example for the MNIST. This is present at the path specified as below. Just a note to anyone who will want to try out these examples on the system, it's recommended to make a copy of the apps directory into your home directory. Once you log into the system, you're directly taken to your home directory, where you can copy these directory tree structure into your home directory, and then you can run them using on that. And then, so as part of any normal application, first you activate the environment. As I've specified before, there are already existing environment under each of these pre-built environment that are under these applications. And if you see under the MNIST application directory, you have that corresponding environment that you can activate. Following that is the compile and the run command, very similar to the one we just saw in the LeanIt in the previous slide, that has the compile arguments, most prominently the PEF file name that you want to provide, and then use that to run your training on the model. Just to be specific, the one previously LeanIt and the MNIST here, they are not provided with any training data in the command arguments, just because these scripts are already programmed in such a way that it downloads and uses the MNIST data set by itself. Then, as a part of the next step, we actually also take a look as to how a multi-node example looks like. From whatever we have seen till now, a simple example like a LeanIt or an MNIST, they are just very small toy programs or applications that can easily fit onto a single tile or an RTU. And then these do not and these examples here that we've shown, they do not they're just running on just one instance. But if you want to run your simple program, using a data parallel framework, and if you want to scale it out across the different tiles or across the different nodes or even across the different racks, there are specific things that we need to take care of. And that is what we will see in this section. And usually the gradient accumulation happens on the RDU, which makes it have a better performance. And if you want to take a look at how a script, which is a combination of the compile and the run commands, are here, I've just used a unit example. The scripts are already present in the same directory where most of the other application scripts are provided, which is under the /data ANL and scripts. Or you can also use the ALCF AI Testbed documentation, which has the steps that you can follow and take a look at them. If you really open up these scripts, the main things that you would want to take a look is that one is the different environment variables, usually that is required for efficient running of these applications on the system. Specifically for the number of OMP threads, which probably usually we set it around to 8, 16 or 32 based on the requirement and the complexity of the models. And there are other several environment variables that are set, and you can reuse them in your scripts too. So for when you run a simple unit example, this is how a compile and a run command look like. For example, this is the single instance where you're just running the unit model on, say, 4 tiles of the model. And these scripts are written for both running a single instance as well as multiple instances. The single instance, you just use the compile and the run command. These are very specific to the kind of scripts that are being written. And if you want to use the multi-instance run, you use the p compile and p run, which p stands for basically the parallel, to ensure that multiple instances of your program are running on different RDUs and across the different nodes. So if you take a look at these scripts, you will see how exactly the compile and the run command looks like. So obviously with any other, as you can see with any other application, first we activate the required software environment. And then we see that for the compile command, you see that we pass the specific Python file, the compile argument, and most specifically when we want to do a data parallel kind of distributed training, the most essential parameter that you need to pass as part of your compile command is the one that is highlighted in yellow here, which is the data parallel and word size is equal to 2, which basically means that you generate a PEF file that is compatible for using it in a distributed data parallel fashion. And once you have compiled with this argument, you can choose to instantiate any number of them, which bare minimum would be 2. And then the run argument, as you see, we use the Slurm resource manager here which is, and we use SBatch so that since we are using a script here to run the run command, we also specify the total number of tasks per node as part of the argument. And also, you can choose the total number of nodes that you want to run. And specifically, you can also choose to specify the node list, which is nothing but the host name, as we have already seen in the previous slides. The different host names with the combination of rack and host, like SN30, R1, H1. You can choose to use that and run on a specific node, or if you do not, then Slurm will allocate the next available node that it has, and then it can run on either of the 8 nodes that we have. So this is to just replicate, this command basically replicates across the different devices. But the actual run command for the particular example here, which is the unit, as you can see, it uses a slurm command again with the srun, and then it uses the MPI. And the main other arguments that you need to look for a data parallel run is the data parallel again in the run command argument, as well as reduce on the RDU. So in this slide, whatever you see that has been highlighted are the most or the essential command arguments that is specific to the distributed training over a data parallel. So some of the utility commands here that I want to highlight is obviously the usage of the slurm commands, which is both the srun or the sbatch. The only difference between srun and sbatch is that sbatch uses you create a script and then you can use sbatch to run it, or individually you can also use srun to run your processes in parallel with the other processes that's and basically the resources are allocated by the slurm. So another important command or the slurm utility command is the SQ, which helps you to check all the jobs that are scheduled currently on the system. As you can see, this is a snapshot of how it looks like one typical user using the system, and it's using the node SN30 R1 H1. And if and when you request for resources, but nothing is available, you can also see that you can be in the pending status for that particular process. And then once any kind of resources deallocated by some other process, then you will be available, the resource will be available for you to step in and your process starts running. Another important command is the SN stat, which checks and you can check the process on each tile or node and how many nodes or tiles or RDUs your application is actually using to run on them. Last but not the least, we also use the sinfo and to get some information of the system, and also the scancel to terminate any of your slurm jobs. So essentially, these are the commands that a user will be using on a day-to-day basis when you're actually trying to get an application up and running. We will cover in detail about the slurm and the associated commands in the future sections tomorrow. But in short, these are some of the major commands that will come in handy while you're using the system. And here are the simple, some of the important paths and directories that you would want to have at your hand while using the system. As I might have already specified about the apps directory where actual application examples are provided. And also there are these model scripts that are useful in kind of like using them and running it at once. And also please use the software SambaNova dataset to download any of your dataset of choice. There are already some major, most common datasets that we use like Pile or Open Web Text under this directory. So please choose to reuse them just to ensure that we do not duplicate the resources on the system. And software and /projects are other important directories where some of your caches or results are stored. And you can look up most of these scripts and use these and you can see that these directories are the places that you want to put all these artifacts on, especially for very large models. And again, just as a reminder, here are the links for the AI Testbed user guide. We have the SambaNova documentation as well. And also the SambaTune, which is the profiler for the SambaNova stack. All these, the details about the SambaTune will be covered specifically under one of the sections tomorrow. Last but not the least, before I move on to the hands-on session, we have the director discretionary allocations open for SN30, and you can use the allocation request form for describing your specific project and how you intend to use the system. Please reach out to us at the ALCF team if you have any other questions, and we'll be happy to help.